Hello everyone, I'm Casper. I'm the founder of Testeroni, where we help our clients make sure that they deliver the software fully cooked instead of half-baked. And here on YouTube, we help the aspiring QA engineers become test automation engineers one slice at a time. Today, we are going to be looking at a very important concept. So there are some concepts which I deem the foundation blocks of test automation, stuff you have to understand if you want to get into the field and then to excel in the field. And those are topics like the pass rate, understanding what a framework is, understanding the page object model, stuff like that. And we have videos on each of these topics on the channel already. So I really recommend you to go there and check them out. And there's one more topic that really falls into that category. And that topic is test flakiness, which is exactly what we are going to be talking about today. And so let's jump to our whiteboard. So to understand what exactly test flakiness is, we are going to do a little example first. And so let's imagine that you have created a test. You have created a test case within your framework, and it looks fine. So let's just say that we have the runs on one side and the result on the other side of this bespoke table. So let's say we have the run number one, which is you have created a test. It seems to be working fine. So you have incorporated it into the framework, and you do the first 4 run, and it's a pass or fail, depending on what you're testing. But by that I mean it is working as it is intended. So for the sake of this example, let's assume that you are testing some functionality that is a happy path, and it's supposed to give you a pass under the current circumstances. So you have the first run, then you have, I don't know, a second run. Let's say it works daily. The pipeline is run daily. And so the next day it's a pass again, and then it's a pass again. And suddenly, by day 4, you get a fail state. And so the first thing you should probably think is that, yeah, all right, so the test did its duty, and it actually found out a problem. So there is a problem within the application. There weren't really any changes, but maybe some devs did something and they didn't inform the rest of the team, and it caused some errors, or maybe something went astray with some other part of the application, or some other department might have messed something up. So you check the fail state, and to you it looks fine. So you don't really know why it failed. And you start to think, well, I don't know, the script looks all right, but it's suddenly given a fail state. So let's rerun it. So you run it again, either locally or in your pipeline, and you get a success. So you think to yourself, yeah, so this thing probably was some kind of a anomaly, something like that. So let's not bother about that too much. And so time goes by, and sure enough, by the next day, it's a success again. However, by day 7, it's a fail, and you test it on your own again, and it's a fail too. So you retest it, and again it's a fail, and you retest it, and it's a success. And now you don't know what actually is happening. You do some manual testing to verify that, and everything seems to be working fine. You ask around, you ask your team, you ask on a daily, for example, whether there was any change within the application, and sure enough, there wasn't. There was no new releases, there was no bug fixes that might have broken something else up. Everything seems to be working perfectly fine, and when you check it out on your own, it surely is. However, you are getting the intermittent fail and success states. They seem to be happening at random. Suddenly, it does not seem like you're actually testing anything anymore. It seems like you are buying lottery tickets for the QA lottery every time you run your test. And so we have a problem. And this exact phenomenon is called test flakiness. So when we are talking about test flakiness, the exact thing we are talking about is what we have just discussed. And it is just one flavor in which this problem may arise. And there are quite a couple of them. And some of them you can't even imagine until they arise. But generally speaking, this is what test flakiness is. So what you have just observed is that your tests started giving out results which were not actually results of something going bad or going well. So they may have been false positives, false negatives. Either way, there was no change within the matter of testing, and yet the tests were giving different results, and it seems as if there was something different. So this phenomenon is called test flakiness. So in order to formalize it after we've done this example, let's just say that test flakiness is the instability of tests despite the object of testing not actually having changed at all. So here you should focus on two parts of that. Is that the problem that happens is the instability, and why that is a problem is that actually there hasn't been anything changing. So this is the whole problem, that you have the instability in your tests, and actually neither the tests nor the object of testing have changed. So this is a common region for headache for beginners, because suddenly you start doubting whether you are actually even in a good field, because there's some not really understandable indeterminism happening. You don't know why things start going astray, because seemingly they shouldn't have. And so this is basically what test flakiness is. And so now that we know what it is, we should look more closely into what actually may be causing it, and what are the symptoms, and how we may go after combating this thing. First of all, however, I think we should look at why that even is a problem. It may be self-evident when you look at it that, yeah, of course it's a problem because it's because of the instability of tests and so on. Yeah, but I think in order to really drive the point home, we need to look further into the nature of test flakiness before we progress. So we understand what it is. Now let's understand why exactly that is a problem. So first of all, I think we should look at the loss of confidence. And I don't mean loss of confidence in yourself, like maybe that can arise too when you are finding these things, and especially if you're at the beginning of your career, they may cause loss of confidence on the side of the tester too. But in general, the loss of confidence in the whole testing framework. And that's the problem in and of itself, because the main thing that your framework, that your tests should provide to the organization and the team is the confidence in the reliability and the determinism of the whole shebang. Because if your tests are not reliable, then why are they there in the first place? The main thing about automated testing is that we are replacing people doing repetitive tasks with a machine, because we know that it'll do it, and in a more predictable, reliable, often faster way, and some other things on top of that, of course. There's another video on whether we should automate everything. I really recommend you to watch that if you want to understand that more deeply, why we need automation in the first place and where it has its place, and where we should just stick to manual testing. But that's on another note. So the loss of confidence is that if your tests suddenly become unstable, unreliable, then it causes the loss of confidence in the whole framework. And if there is a loss of confidence, then how can you or anyone in the team or in the project trust your tests anymore? The goal of your tests is to be able to look at them and know if something is wrong or something is right and not worry about it ever again. And your job is to keep them up to date, to mitigate the risks and problems from the side of the application and stuff like that. So you need to maintain them, of course. They are not going to be like evergreen, but still, if they are there, they should be performing well. And if they are not, you should know exactly why, and usually before they even start misbehaving. And if they are seemingly behaving well, and suddenly they start throwing various results at you without a clear reason behind that, then what really is the point of having them there? Like, your whole framework is suddenly a little shaky, isn't it? So keeping that in mind, the loss of confidence is inevitable, and then also the sense of your tests is losing its meaning a little bit. So the loss of confidence is a big one. Another one, which we should look at, is the cost. And I don't only mean the monetary cost. This is very important also. Like, if I remember correctly, Microsoft once said that the test flakiness was causing them something like $1 or $2 million a year in the project they were talking about. So there's some serious money involved. But I mean the monetary costs and the time costs, because the test flakiness occurrences are a pesky little bunch. So they are pesky creatures, and so they may creep up on you when you least expect them, and they may cause a whole lot of havoc in the team and in you when you are looking for them. You are burning up the organization's time. Your time also costs money, so that's also burning money. But the costs are evident. There are costs that are the result of the flakiness happening, because you need to then nail it down. You need to find it. You need to fix it. You need to... And it takes some time to find the flakiness, believe me. And we are going to talk about it in a second when we dive deeper into what the actual causes may be. But it takes some time, and very often you may need to also use the help of other people. And so the cost is pretty evident, not to mention the costs of rerunning the pipeline again and again, sometimes re-triggering the build, or like the whole time needed to test it, retest it, fix it incrementally, try to do something about that. So it does take some time, and also it brings some costs with it. It may very well, in an organization of like a smaller size, cost the project, for example, a delay in a release, because suddenly the whole release cycle is somehow hindered by your framework not really working like it should. So yeah, there is some hidden costs, and there is some very evident costs on top of that too. So the cost is everywhere. And thirdly, there's the chaos that ensues afterwards. So we have touched upon that a little bit when we were talking about the cost, but when you have such a problem and you don't know you have a flakiness problem, very often you will bring other people into the equation. You will start asking around, you will start spreading the doubt whether something is working properly or not, whether someone else might have broken something. And so when other people enter the equation, you are suddenly a group chasing, like playing the inexistent game of catch with the whole pipeline, the whole framework, the whole release. So you are playing catch up with a really fleeting concept of test flakiness, because when you don't know that something is caused by flakiness, then the problem is like tenfold the magnitude that it would have been. Test flakiness is pesky in and of itself, like I said, and it's pretty often pretty hard and time consuming to find it. So we'll talk about how to prevent it also in the future. But the problem is that when chaos arises and everyone is like trying to catch the fleeting test flakiness, it's even worse, because you don't know what you're chasing, and the results are not really helping, because they are, like we have shown in the example before, they are seemingly random. And so this causes chaos. And so we have all of these three of these problems. Like, these are very generalized groups of problems. Of course, we can dive even deeper and we can talk about all the other things. But these are I think, the most important ones that you should understand in order to get the big picture of why actually test flakiness is a problem. And so now we know why that is a problem. We know what it is. We also know that test flakiness isn't really a fun game to play, but that doesn't help us with combating the test flakiness, like so far. So, like, first of all, we should understand that chasing test flakiness is not a fun game to play. Like we have already talked about, it costs time, it costs chaos, it costs money also to the organization, and it costs a lot of head scratching from you if you want to actually get to the bottom of it. And so your goal should be to prevent them in the first place, but if they arise, you should be prepared to know what to do. The problem is, test flakiness is not really a well-defined, clear-cut problem. Like, it is a class of problems. So the fact that something is causing instability and that it is not really predictable anymore is not a specific problem that I can just give you a solution for. I can't really give you a prescription of, if you have test flakiness, just check these keywords and it should be okay. Sadly, it's not really the way that it's going to go down. So test flakiness is fleeting and it's not a fun game to play, mainly because it is a class of problem. Test flakiness is more of a symptom than it is the underlying illness. And this is what we are going to try and unpack in these next few minutes, because test flakiness, like I said, is a group of problems. You may observe that test flakiness is taking place, but actually under the hood, there may be 8,000 things happening, sometimes in unison. So you need to be able to tackle them. And so let's talk about the most general groups in which you should look for the problem of test flakiness if one arises within your framework. So let's scroll a bit. And now we're going to answer the question of what may cause test flakiness. And the first one, and I would say the most common one, so it's a good idea to start from that one, is the application not loading up properly. And what I mean by that is that when you are performing your assertions, you should be 100% sure that the object of your testing has already been loaded up. And it's very often easy to overlook that, because when you are interacting with the application, the website, the object of testing, whatever, you are not really paying that much attention to the order of the elements, for example, the order in which elements are being loaded up in the application. Usually it's so fast or so slow that, depending on your project, that it's not really something that you are thinking about when you are manually going through the app. And so it's easy to overlook that and to just go merrily testing things and creating your script, going point by point, but not really thinking about what is happening between these points. So one thing that I want you to always remember and always focus on is that you should remember that the steps you put within your test case in your framework are going to be, I'm making a huge generalization here, but bear with me, are going to be executed immediately. That's a good idea to think about it like that. The steps I am putting down are going to fire immediately, one after the other. And of course, there are some exceptions. There are some keywords which are waiting for element to happen. There are some frameworks which automatically should take care of waiting for the elements, like Cypress does that, for example. And so depending on the choice of your framework, it may be more or less automated, and depending on what you have on the website and whether it's more or less dynamic, it may be easier or harder. Let's not get into the nitty-gritty of that. Let's just focus on the big picture. And the big picture is that you should, when you are creating your test script, you should think about it as if it was a sequence of commands that is going to fire immediately, one after another. And then you should start to think about how I may ensure that the next command, when it fires, the application is in a state that is ready to take it on. And then the thing like, yeah, my framework takes care of that on its own, come into play. That's when you think about it, not when you're creating it. You should always focus on, when you are creating it, on making sure conceptually that what you are putting down in your IDE is actually going to be run at a good time. And so this is also why we have weights in when you are creating something in like Selenium or Robot Framework. You need to, of course, these are different kinds of weights, but let's not get into it that deeply. You should be able to structure your weights in such a way that a given element is always ready for testing when the assertion for it arises. And this also usually, or sometimes, may result in you being more of a detective than being a QA engineer, because you are thinking about stuff like, very often you can't just wait for the object that you are going to assert on to appear. You sometimes need to wait for some other part of the application. So you are thinking about strategically about the order of operations and the order of elements loading up, and you observe them and you think, yeah, so when this loads, then this should show up and this is available and I am testing that. And this is a whole tree-like structure that like is emerging in your head, but that is the way to go. You should think about that in order to be able to know that it is not going to hinder the performance of the test, because this is why flakiness may be happening. It may be that you are not waiting for something to really be present in your application before you start testing it. And so when you are in luck, it is available, and then you get a success. And when you are not, because something like started lagging, or the thing you are trying to test is not there yet, then suddenly you are getting a fail state. Even then, like 30 milliseconds later, it would have been attainable for the test. So you always need to make sure that the application is loading up properly. There's a couple of ways to do that. Like I say, the most generalized one is to structure your weights in such a way that the assertions are taking place when they can actually get to the thing that they are testing. In such situations, I also often recommend people to think like a machine. And by that, I mean, go to the website, like try to remove all the preconceived notions or how the application works. Go to the website and think algorithmically like a machine, and try to go explore the application, and through exploratory testing, try to get to what you're trying to test, and observe in the meantime what must have happened in order for you to be able to actually test that thing, and then just put it into your IDE. Of course, that is easier said than done, but that's the life of a test automation engineer. So I recommend you get used to it. But generally, just try to really make peace with your weights so that you are actually ready for testing when you should be. The second thing are unstable environments. So, and we will have another video like focusing specifically on environments, because you should understand why the environments are there, what's the difference between like develop, pre-prod, prod, and I don't know, integration, or like pre-prod 2, or however it's called in your organization, because these names also get wild very often. So that's for another day. But the unstable environment may be enough to actually cause flakiness in your test, because when you have an environment which is unstable by nature, for example, it is lagging, or something is crashing there, or there's some downtime from time to time, it may very well be that your test is perfectly fine, but the environment in itself is causing some issues. And of course, in some situations, it is understandable that lower environments are going to perform worse than like higher environments. You wouldn't really expect the development environment to be as stable, fast, and like predictable as the production is. But having said that, you still need to somehow work with it. And so one of the ways you can try to mitigate that problem is by providing separate configurations for separate environments. It depends on the nature of the problem, of course, but if the problem is just that a given environment is working slower, then you may try to just have a separate config files for each environment, and when you are, or like pass an argument in your Jenkins that you are allowing for longer timeouts, for example, so that the tests don't time out as quickly as they are on higher environments, for example. Or you are running them in a different way, you are running them with a different configuration, you are running it in a different manner by providing some environmental files which allow for more leeway for your tests to actually combat the instability of the environment. Either way, instability of your environments is something you are going to come across in your careers a lot of times. And it is not only the basis of test flakiness, it is also a basis of a whole lot of other problems. But you should also take into account, when you are looking for test flakiness, the instability of the environment, because this may very well be an issue too. Thirdly, we have the problems with concurrency. So when tests are being run in parallel, which is very often the case and very often a good idea also. So when they are run in parallel, there may arise some problems called race conditions. So when you have tests running in parallel, generally they should be as independent as possible. They ideally should not ever cross paths with each other. And this is the ideal state, of course, but you should strive for that. And very often it's not the case, and suddenly you have tests fighting for the same resources or the same accounts or the same things within the application, and just trying to grab it from one another's face like all the time. And then whichever one comes first suddenly is working as expected and all the other ones fail. So concurrency and the race conditions that stem from it may actually cause quite a bit of headache. So even before you implement concurrency in your test framework, you should already start thinking about, if these tests were running in parallel, would they be still as operational as they are now? Because even if they are not running like that now, it is a good future-proof solution to think about it like that, and also a good way to think about the tests like in and of themselves. They should be as independent as possible, and they should be able to not really fight with one another when you try and run them simultaneously. The fourth thing are the external dependencies. And by external dependencies, I mean things like databases, APIs, so stuff that you are going to be interacting with, because one way or another, your tests are going to cross their paths with things that are external to them. It's not like they are going to, like the application itself is an external dependency in and of itself. So you won't have the luxury of knowing the ins and outs of everything just as much and to the same extent that you know the ins and outs of your own framework. And so you need to be ready for working with external dependencies, because very often they may pose a problem and suddenly there is some cooldown needed, because, for example, the API has some cache underneath. And if you are not waiting for a specific time between the calls, then suddenly something is not working, not because it is broken, but because it just needs a couple of seconds to clear the cache. Or you may have problems with the database, that it's more functioning sometimes. And sometimes this may be a good point to raise, because it may be that by running your tests, you have actually found out that something is so wrong with an external dependency that it needs to be looked at. It's not like you should discredit anything that is found within the external dependencies because, it's the external dependencies, you don't need to worry about that. It's not so easy. Sometimes the external dependencies are your problem, and your tests are finding out bugs not only in the application like front end and the immediate back end. Sometimes it's way deeper than that. So you shouldn't discredit it by default, but either way, you should think about the external dependencies in a way that it may be a possible culprit if you are experiencing test flakiness. So one way to combat this, and the first one that comes to mind, is something like using stabs or mocks or some other prototypes of things that may not really communicate well during testing. So you have some mocked database, and you may have some mocked calls and stuff like that. Ideally, this should be possible. However, sometimes it is time-consuming and not really relevant to a project. And very often you will need to work with the external dependencies, like working with the real-life organism, and just live with that. And you will need to kind of settle with all the advantages and disadvantages that come with it. And there are a couple, but so the good thing is that you are working on the actual thing. The bad thing is that you may need to work with something that may cause some flakiness. And this also sometimes entails just talking to other members of the team or your project to actually learn about the limitations of other tools, which are not only within your framework. So I really recommend you to try and think about external dependencies as the possible source of your test flakiness. It may not be the only reason why something is breaking, but either way, it's good to think about them and to think about how you can combat it. And if they are a common enough issue and they can't, nothing can be really done about it, like immediately, then maybe it's a good idea to think about mocking some of these behaviors so that you have the controlled environment for your testing. Because what you are ultimately struggling for is the controlled environment so that not too much things can get in the way of the tests. And the most external dependencies you get, and the more of them you stack on top of each other, the more uncertainty happens to your tests. And this is why the tests may start to lose their significance pretty quickly when you add a whole lot of things on top of them. However, like I said, depending on the project and organization, it may not be that easy to actually bypass that problem. And as number 5, last but certainly not the least, I am listing mistakes. And by mistakes, I mean the actual technical mistakes, problems, errors on your side. So things you have caused yourself by not giving, by not providing as much value within your code as you might have. And I don't mean anything deliberate, of course. I mean that very often we take a lot of our knowledge for granted, and we take a lot of architecture that comes with it too. And we get a little lazy, for example, with the naming, the linting, the error checking, peer reviews and stuff like that. So it may be that there is just a coding problem within your test case. It may be that there is some problem with the syntax, with the operations. It may very well be that there is just some mistakes within your code, and it's nothing really to fret about, but you should always try to bring your code to the highest possible quality before you ship it out for working within your framework. And it's easy to overlook that because something looks all right, so why bother checking it further? But later down the line, it may really snowball into something like test flakiness. And I also want to be frank with you. I think this is the least possible cause of test flakiness. So if you are now thinking, oh God, I am a bad test automation engineer after all. No, I'm not trying to go about it like that. I just mean that mistakes happen, and it is always a good place to start looking for the reason of something going wrong with your test. And it is always a good reason because it is also the easiest the easiest place to fix. Like if there's just some syntactic error, or if you just made an error, like an off by one error, or you used a wrong keyword or stuff like that, then it's pretty easy to fix. Even if it takes a little bit to get to the bottom of, it's still the easiest one to fix most often. And sadly, that's also why it usually isn't the problem or the main problem. Usually, if something is like an actual technical mistake within the test case, and I don't mean like the lack of documentation, because yeah, we are all guilty of that. I mean the actual technical problems which cause the malfunction. If something is a mistake of that sort, usually the test is running badly from the beginning. It's really, really rare that you will have made such an error that it goes unnoticed through the whole like peer review process, and it is incorporated in the framework, and it is working fine locally. It is working fine in like your CI/CD tool, and then suddenly it starts misbehaving because something else happened in the universe, and it suddenly is not working properly anymore. Yeah, it may happen, but it's a really rare occurrence. So I'm not really... That's why I'm talking about starting from it, not because it is the most possible reason. I think the most possible reason remains number one, but it is the easiest one to nail down, and you may find some really easy, simple errors there that you may just fix. And even if they don't like cure the flakiness, they may cure other problems that appear later down the line. Either way, you should really look into your code and just try to provide the highest value that you can. So having said that, we now know what may be the cause of the flakiness also, but still there is one more problem. We have talked about how we can actually go about fixing these things or trying to fix these things as we find that they are the problem. However, as I was also hinting during my talk about all of this, there are situations in which you just need to work with whatever you are given. You need to play the cards you are dealt. And so in such situations, you can't sometimes really fight the problem. Sometimes there are some external dependencies which you can't bypass, and you can't just easily use mocks without going through the organizational hell of like applying for all these things and all these permissions. Sometimes there is some instability in the environments, and you just need to be able to test the unstable environment. And the list goes on. Like at every point, I was hinting at the way you can try to actually fix it if you go about fixing it directly. Sometimes, however, you are not able to fix them directly, either because of some organizational or project or team limitations. It depends. But either way, sometimes you just need to do something to make it operational without being able to actually fix the underlying issue. And so let's now talk about, if I wanted to bring all the ways you can try to combat test flakiness in like generalized points, what I would recommend you. So the first thing you can try to fight that off is to incorporate retries. And what I mean by that is that most modern frameworks already have a built-in solution, and if they don't, they have a well-established library that takes care of retrying tests which have failed. And by utilizing such a library or such a functionality, you are actually allowing for the flaky tests not to hinder your performance and not to give false negatives just because of stuff you can't really fix or you can't really influence. And once again, I want to underline what I started with, that you should understand why it's happening. So I'm stressing that because if you are just trying to incorporate retries to get a greener report that looks prettier, and you don't really know why the flakiness is happening, but to hell with that, let's just retry until we get a satisfactory result, then you are not really doing testing anymore. You are doing like report painting at that point. And I also have another video precisely on that topic called "You Are Not Your Pass Rate," which dives deep into why your goal as a test automation engineer is not to get as high of a pass rate as possible, because this is not something that is your ultimate goal and ultimate achievement or something that defines you. And so you shouldn't use retries to go about it like that. I really recommend you to go to that video and check that out to understand why it's not the like point of your existence as a test automation engineer to get a green report. But either way, you should first understand why test flakiness is happening, where it's happening, and if the reasons for which it's happening are really not possible to be mitigated, fixed, or bypassed. And if you understand all of that and still you come to a conclusion that you can't do anything about it, then it's good to do retries, because then you are just working with, you are working within your limitations and your situation, which is not ideal, but you still need to provide as much value. And in this case, the value you are providing to the project is that you are testing whether something is working, with all the people knowing that sometimes it may not be working because of some other stuff that is either being taken care of or not being taken care of. This is very often not your problem anymore, but you have already communicated the problem. You know that the problem is there. You know that you can't do anything about it. And until something is done about it, it's a good idea to incorporate something like retries, so that you are not getting red when the test is okay and the application is working fine, apart from some element, like apart from the fact that sometimes it is lagging, and everyone knows it's lagging, and the servers are slow, and nobody is going to do anything about it for some time. So in such a situation, sometimes we may also go about skipping some tests in such a situation because they are not representative. But it depends. Very often it is a good idea to just do a retry of the whole test, or to provide, like for example, in Robot Framework, you can retry a specific keyword, so a specific step within your test case, if it has failed, and you can give it the maximum number of retries it can do. And in such a situation, if you know, for example, that very often your tests are, for example, crashing when you are logging in or when you are submitting some form, because there is a lot of things happening in the background and it just takes a lot of time, and sometimes different things may load up in weird order, or the times are weird and it just takes too much time, or something like that, that you can just provide a longer timeout because the timeout is not the problem. Stuff like that. Sometimes it can get really complicated, especially in like corporate environments. So very often in such a situation, you can't really untangle that spaghetti of problems. So you can just incorporate retries and then go about it like that. Then you know that when you know a specific point, when a problem is happening, you may just allow for that specific point to be retried, so that you know that the general like outlook is positive or negative, regardless of whether this specific point happened to be a problem, because everyone knows that is a problem. Number 2 is to care for your code. And by that I mean also something similar to what we discussed before with the coding mistakes. So in this situation, what I'm suggesting you to do is to care for your code from the get-go. So you shouldn't care for your code only after it starts misbehaving. You should start way before you start writing down any code. You should actually be thinking about what it's going to be structured like, how it's going to work. You should take care of your like syntax, of your linting tools, of the errors that may arise. You should try to like talk with other people if you have problems. You want to have your code properly reviewed. You want to also like get better at the thing all the time. That's the nature of learning any skill and any expertise. And so you should just care for your code. So if one of the best ways to mitigate the fixing of your code after like you find test flakiness or stuff like that is to have a good code in the first place. So you should strive for writing good, elegant, clean code from the beginning, and in such a way you are going to mitigate the risk of finding some weird bugs later down the line. And thirdly, similarly to how you should care for your code, you should also test your tests. And by that I mean, when you create a test, don't just be satisfied with seeing green and then you go send it for peer review and let's just dance because everything is fine. You should try to actually undermine your own thinking. You should try to contest your own notions of how it should work. You should try to, in your mind, find counterexamples. You should think about stuff that might go wrong, and you should think about external stuff that might go wrong too. Just as much as in care for your code, you care for creating the best possible code. In test your tests, you are trying to think of the worst possible environment that it can be run into. You should think about the worst possible landscape that is around, and it still should perform well. And if it doesn't, you should be prepared. So when a problem arises, you shouldn't be caught off guard because you haven't thought about it. You should be like, yeah. So that's one of the things I thought may happen. It's not something under my control, because if it was under your control, you should have fixed it already. You should have had countermeasures ready. But it's not something in my control. But yeah, I know that such an external dependency may influence something, for example. So you should also test your tests both locally and just in your mind, trying to find counterexamples and how to combat them. This is similar to what we were talking about at the very beginning, that you should think about, will this weight work in such a way that I think it would? Will this specific assertion fire at a moment that I am certain the application will be ready? Will this or that keyword or this or that command or this or that operation work on something that is ready for testing? And stuff like that. You can just go one by one and try to make sure that it all makes sense. And so, having said all of that, we now know also the generalized solutions, but test flakiness still is a gigantic topic, like any topic if you want to really get to the bottom of it. Today, we have tried to cover the most important aspects, and as always, I am trying not to overburden you with too much information. I am trying to give you the foundation which you can expand upon in your career, because that's also the best way of learning. It's not like just listening to me talking to you. I am here to give you the fishing rod, and it's your job to go into the field and actually catch some fish. But this is a overview of a gigantic concept. So of course there are other ways to mitigate the problem. There are other causes of test flakiness. There are other things which may be worrying if you are thinking about test flakiness, of course. But having said all that, we have now brushed upon the most important aspects which make you ready to actually dive deeper into it and understand what is happening. And so I think we are ready to go to our final thoughts. So first of all, once again, test flakiness is the instability of the test's results despite no changes in the application code. Number two is that it is a phenomenon that undermines the reliability of your tests. So we have already talked at length about both of these two things. So this is why I'm not stopping for too long at them, because the first one is the definition that we have tried to tackle from various angles for the whole duration of that video, in order to be able to understand that it is the instability of the test results, even though there were no changes in the application. And the point number two is that the main overarching problem is that it undermines the reliability of your tests. And the reliability is everything. This is why you are creating the tests, to find bugs, problems in a reliable manner. If you are failing to do that, there's a big problem, because your work is starting to not really provide the value that it was supposed to. And thirdly, the best first step and countermeasure to combat it is to make sure your code is clean and the reasoning behind it is sound. So this just brings us to the thing that we talked about just a moment before, which is that you should care for your code and you should test your tests. So basically that means take care of your code to make sure that it is clean, elegant, concise, and make sure that the reasoning behind your code and behind your tests is sound. If I were to give a one sentence recipe for trying to not fall into the pit of test flakiness, it would be this. The first step and the countermeasure is to make sure your code is clean, to make sure your code is clean before you are creating it, when you are creating it, and afterwards when you are maintaining it. And the reasoning behind it is sound because you should have a clear idea of what you are creating before, during, and after. And you should be able to actually debug the steps of the test case in your head and make sure that the test is able to perform under the most pesky of weather conditions. So let's say that it may actually encounter in the application. And so try to make sure that your code is clean, and always be sure that the reasoning behind it is sound, and it'll be a great service for you in the long run, basically, in all the topics and all the fields that you may come across. And having said all that, I thank you very much for your attention in this introduction to the concept of test flakiness. Be sure to subscribe and like the video here on YouTube, and to visit us on Facebook, on Instagram. And I thank you once again very much for your attention. I wish you all the best with further learning. If you have any ideas, problems, propositions, or if something was not really clear, or if it was clear and you really liked it, just be sure to leave a comment here on this video. And as always, thanks for watching and keep on rocking.